In this question, the electric field inside a sphere which carries a charge density proportional to the distance from the center, rho equals to alpha, alpha is constant. So we have to find the electric field. Now here we have to be very careful. Here rho is given as alpha. So basically rho is not constant. So we will not use the formula directly as rho r by 3 epsilon naught, because that will give you a wrong result. So let's try to find it out, how to find the electric field. So for that case, what we are going to do, we will be considering a sphere. Okay, let's say this is our sphere that we have, and in a sphere this is the center of the sphere, and then we will consider a spherical cell. Okay, because this rho is varying radially, so I will think of an element which will have a symmetric distribution. Okay, means all the points on that element should be at same distance from the center, and on this element everywhere radius r is constant. So I will assume that rho is almost constant in this shaded region. Definitely this element that I have considered, this element is a spherical cell that has a thickness of dr. So in a range of r to dr, I will assume that rho is invariable because dr is tending to 0. So we can assume rho to be constant. So if I have to write the electric field at this point, then I will calculate the charge enclosed by, because using Gauss theorem we can see that E into, let's say, 4 pi r square, that's the flux through this, that's the flux through this surface, okay, through this sphere, that should be equals to the net charge enclosed by, that is Q enclosed by epsilon naught. So E is how much here? E, you can see that is Q enclosed by 4 pi epsilon naught times r square. So our main task is to calculate Q enclosed. How to calculate Q enclosed here? So to calculate Q enclosed, I will say that consider a ring of radius r, consider a hollow sphere of radius r and thickness dr. Consider hollow sphere of radius r and thickness dr. So if I write dq on that element, dq will be how much? So dq will be rho into dv. dv is how much? So hollow sphere has a surface area of 4 pi r square and thickness is dr, that is dv times rho. Now I will substitute the value of rho here because rho is variable. So alpha r, and then this is 4 pi r square dr. Okay, so for Q enclosed, if I write, then I have to simply integrate it, alpha r 4 pi r square dr 0 to r. Now I will take the constant out, 4 pi alpha r constant that we can take out, and this is r cube dr 0 to r. So in this case we will be getting here as pi alpha r raised to the power 4, pi alpha r raised to the power 4, that we are getting. Okay, so this is our Q enclosed, pi alpha r raised to the power 4. So if I write the value of electric field, then electric field will be Q enclosed by 4 pi epsilon naught times r square. So if we substitute the value of Q enclosed that we have calculated from here, pi alpha r raised to the power 4, and then I will be writing 4 pi epsilon naught r square. You can see that pi and pi will cancel and r square and r4 will cancel, so we will get alpha r square by 4 epsilon naught, alpha r square by 4 epsilon naught. So correct option is option B.